So today's date is March. Yay! Who'd ever know it was March, huh? From the weather. So 318, and Common Core said we're going to be finding roots from polynomials. Okay, so write that down. Let me do a little talking, okay? So polynomials, we know from way back before vacation that if the exponents are whole numbers, they're polynomials. Remember that? And they're curvy. Remember that kind of curvy, right? We also have learned that whatever the degree is, that's how many zeros they'll have, right? X squared, 2 answers, x cubed, 3 answers, x squared, 2 answers, right? Now there's a difference between what we call a zero and a root, okay? Zero and root, okay? A zero is literally going to be the same thing as an x-intercept. But roots are any answer that makes it equal 0, okay? So if that includes i's, so with roots you can have imaginary answers. Okay? So if you've got any answer that makes it equal 0, that's going to be a root, okay? And including i's, all right? So we take a look at the first one, and it says find the roots, this is factor, and then we'll also look at the graph. So if you want to find roots or zeros, we're going to first set it equal to 0. So set equal to 0, and then we'll solve, all right? So on example 1, we set it equal to 0, so we got 0 equals x squared minus 9. Okay, and make sure I'm not going too fast. I'm okay so far, right? And then it will factor. It'll factor into an x plus 3, x minus 3, right, equals 0. And then I've got my little mini equations, and I could set them equal 0 and solve, but I think you guys know that if I did that, I think you'll agree, negative 3, positive 3, right? If you set them equal to 0 and solve, everybody's good on that, right? To get negative 3 and positive, right? Okay, so that means on a graph, we should have at negative 3, we should have a 0, and at positive 3, have a 0. Now, I know the graph looks something like this, okay? And you can look at it on your calculator. It does go down to negative 9 right here. But if we look at it on the graph, and I'll show it on the calculator real quickly. Okay, graph y equals, clear that out. So if you do just your x squared, yeah, it's terrible, I know. Someday we'll figure this whole overhead thing. X squared minus 9, window, there we go, negative. If we go negative 10 to 10, there it is. And sure enough, that is at 3, and that's at negative 3. Oh, somebody's been messing with my format. Grid on. Oh well, either way. Okay, example 2. So before you even start example 2, how many answers? 3. You guys agree? We have to have 3 answers. You guys agree with that? So if we were to factor example 2, set it equal to 0, set it equal to 0. Okay, I agree. Katie says 3 answers, right? If we factor out an x first, right? And then we'll factor again into an x plus 2, x minus 2, right? How am I doing? So far, so good? Okay. And then my answers are going to be 0, negative 2, and 2, right? So 0, negative 2, and 2. What does the graph look like? The graph, if I put it in my calculator, does look something like this. And you can put it in your calculator. I will. I'll put it in my calculator and I'll show you. So you see it. If I put the original x cubed minus 4x into the calculator, okay, there it is. Okay, and then if I push graph, looks like that, doesn't it? And it crosses at 0, negative 2, and 2. We know that from the factoring, right? All right, how am I doing so far? Okay, now, example 3 is different. Okay, example 3 is different. Let me graph it first. So example 3, 1, 2, 3, 4. Example 3 looks like this. Okay? So if I look at example 3, Jacob, you guys, Nellie, shh. If I look at example 3, it does not cross the x-axis, right? So it doesn't have any zeros. There's no zeros, but it has 2 roots. I'll say it again. It has no zeros, doesn't have any x-intercepts, has no x-intercepts, but it has 2 roots. Okay, now the way we're going to find the roots is just by solving it. So we know if you set it equal to 0, x squared plus 4, right? Because the graph won't give us any answers. The graph is not going to give us any answers because it does not cross the x-axis, right? But let's solve it like we've done before. Minus 4, right? Square root, how many answers? Square root, how many answers? Square root, how many answers? 2. So it's going to be plus or minus the square root of negative 4, right? Right? And because of the negative, we're going to have an I. We're going to have an I. So my 2 answers are plus or minus 2i. And those are its roots. Now, one of the things I want to show you, and you can just watch, you don't have to do this, but I'm going to do a real quick check. So if I plugged in the 2i into here, I'd have a 2i squared plus 4, right? Which is a 4 times I squared plus 4. What's I squared equal? Remember what I squared equals? Negative 1. So we'd have a 4 times a negative 1 plus 4, and sure enough, that answer would give me a 0. All I want to show you is that whatever answer you get, it will give you an answer of 0, okay? It's a root, okay? And it does work, doesn't it? Even though it's an imaginary number, it still is a root, okay? How am I doing? All right? Now, let's move on to number 4. So number 4, we're not going to graph, but we're just going to factor it. So if I take a look at 4, before I do anything on 4, how many answers? How many answers? 3. Everybody agree with 3? So, again, set it equal to 0. Okay.
Can you zoom in?
I can't once I start to record. I'm sorry. It will not adjust. Okay. Of course, our seat's closer. Anyway, I'm going to common factor out of 3x. Okay. I'm going to common factor out of 3x because I can. So then I'll have an x squared plus a 6x plus 9. Right? I can factor this again. I can factor this again because I know 3 times 3 makes 9. That also adds to 6. I know 3 times 3 makes 9, but it also adds to 6. So I'll have an x plus 3, x plus 3. Okay? As my answers, I'll get one answer, x equals 0, from 3x equals 0. I'll get x equals negative 3, and I'll get x equals negative 3 again. Now, we still got 3 answers, even though 2 of them happened twice. That's called a double root. So my double root is when one answer occurs twice. Okay, does that make sense? Graphing it, if you were to take a look at a graph of this, the graph looks something like this. Okay? Graph looks like this.
We can't see the graph.
Okay, the graph looks like this. You don't have to know what it looks like yet, but the graph looks like okay. And we're going to learn more about this tomorrow, but what happens is right here at negative 3, it touches it twice. It, in a sense, goes through negative 3 and then back through negative 3 again, and that's why it's Looks just like that. Just skims it, doesn't it? And so that's what we call a double root. It really goes through -3 twice. In a sense, think about this. Goes through it, comes back down, goes back through, okay? And that's what makes it a double root, okay? All right, example 5. A polynomial has roots of 3, -1, and 2/3. Find this polynomial, okay? So we're doing Jeopardy. What we want to do is take these answers, like we did here, and put them back into factored form. Or we took these answers, we took them, put them back into factored form. So the way I end up getting x equals -3 is from an x minus 3 equals 0. Okay, think about that. If x equals 3, then it came from this equation. Do you agree with that? I mean, if x equals 3, I bring back the 3, it came from this equation, right? The way I got an x equals -1 was from an equation that came from x plus 1 equals 0. Now that makes sense, right? I mean, this answer, this question would give me -1, x plus 1. Okay. And the way I got an x equals 2/3 came from a 3x equals 2 or a 3x minus 2 equals 0. Okay, and I'll let you think about what I did there. Okay, plug the x equals 2/3. I've multiplied by 3, right? Multiplied by 3, and I brought the 2 up, okay? So my polynomial, let's call it p of x, would have to be this. It would have to be x minus 3, x plus 1, and a 3x minus 2, okay? So this is the question. This is the question that would have got me all 3 of these answers, right? Isn't this the question that would have gotten me these 3 answers? So we're just doing it backwards. Here's the answer. What was the original polynomial, okay? Yeah, Katie?
Do you want us to put it into standard form, or is that good enough for you?
Okay, let me answer that question. Really good question. Here's what I want. I like this answer better for you. Not for me, but for you. Because you're going to get this answer, and then you're going to make a mistake multiplying it out, aren't you? So Katie, for you, leave it there. Some books, some math teachers want you to multiply it out. I just want to know, can you get this answer, okay? Great question. Yeah. So Katie, if you make a dumb mistake, you already got the right answer, right? Dumb mistake. And then you're like, oh, I missed it. I'll keep it like that. You agree? Okay, turn the page. You guys ready? Turn the page. Okay, now, irrational roots. They come in pairs, and we already know this. So in example 6, I'm just going to, it will not factor. Will not factor. So I'm going to go, all right, I can do this. X squared equals 24, right? Girls, you with me? Square root it, but that's what you meant, right? So I'm going to go to there, and then I'm going to go, and we're going to square root. How many answers? 2. So I've got x equals plus or minus the square root of 24, which is correct, but I'm going to break it down. I'm going to give it a better answer. That is not wrong. I would take that answer, but I'm going to take it further because I'm a math guy. I'm going to change it to, yep, plus minus 4, plus minus 6, square root of 6, square root of 4, right? I would take this answer, but I'm going to take it further, okay, just because I can. So I get x equals plus or minus 2 square roots of 6, okay? How's that?
Good.
Thumbs up? Okay, example 7. Well, it won't factor. Doggone it. So we have this beautiful, wonderful, just beautiful formula called the quadratic formula. Yeah, so it doesn't factor. We're going to use our quadratic formula. So in this case, we know A is 2, B is -4, right? And C is 1, right? Okay. So we're going to go negative B, which is going to be a -4, right? Plus or minus big square root of B squared, which is my -4 squared minus 4 times A, which is 2, times C, which is 1. It is a negative. Yeah, it's got to be a -4, right? Because we got a negative B, but it's a -4, right? all over 2 times 2 because a is 2, okay? So just plugging the numbers into the quadratic form, okay? Negative b, so it's a negative 4, plus or minus b squared, which is negative 4 squared, minus 4 times a, which is 2, times c, which is 1, all over 2 times a, which is 2, okay? Jacob, you good?
I was a little bit curious why you put the double with the negative.
Right, and now you see it, because the form's got the negative,
But it just
and
comes out to a positive.
it sure does, so let's just do that now, right? It seems kind of silly, doesn't it? So Jacob's right, let's go 4 plus or minus square root of a 16 minus 8 over 4, okay? Which is 4 plus or minus the square root of 8 over 4, right? Which is 4 plus or minus 2 square roots of 2 over 4. Ooh, where did the 2 square roots of 2 come from? Ooh, better do a little side work. Square root of, yep, square root of 8 is the same thing as square root of 4, square root of 2, right? Little side work, right? And so my answer is going to be a 1 plus or minus 1/2 square root of 2. Okay. You guys see where I got the 1 from? 4 over 4, and the 1/2 is from 2 over 4, right? Good, Jacob, sure.
I haven't quite figured it out myself yet.
Okay,
Let
all
me
right.
say.
Okay, so you're okay to hear, aren't you? You okay to hear?
Yeah.
So I changed the 8 into 2 square roots of 2, because I could change the 8 into 4 and 2, which makes 2 square roots of 2.
And then did you just cancel out the 16 because it's 4 and
Oh, no, I just went with 16 minus 8. It's just 8.
Oh.
Oh.
Yeah,
You're making that too hard, aren't you? I'm good.
Where'd it go?
Here you go. What's 16 minus 8? That's just 8, right?
She
Yeah.
confused me because she asked me earlier.
That's all. It's all good. Antlin, you thumbs up? Yeah, okay, good. Okay, tell me when you're ready for the last one. Ready for number 8?
Not really.
Yes.
How many answers?
4.
There has to be 4, right? So let's see if we can get 4 answers, okay? So I'm going to factor it.
Yeah. That's okay.
Okay? X squared. Okay, you're out with x squared. Plus 9 minus 9, okay? That makes sense, right?
Yeah.
This won't factor again, but this one will. So x squared plus 9 won't factor, but this will factor into an x plus 3, x minus 3, okay? Well, I got 2 answers for sure. I got 2 answers, bam, right here. And do know that x is going to equal negative 3 and x is going to equal positive 3 because I'm just taking these 2, right? That's it. I got 2 answers. Now, I told you there's 4 answers, right? So I'm going to take my x squared plus 9. It won't factor, but I'm going to solve it, okay? Because I'm many equations, right? So I'm going to solve this. So I'm just trying to solve that one there. And minus 9, yeah, you're ahead of me. I like that. Subtract 9, right? Negative 9, right? Square root, right? Square root. How many answers? 2. 3i, right? So we're going to get x equals plus or minus. Square root of 9 is 3, but we got a negative, so 3i. And there's my other 2 answers. I do wind up with 4 answers. I get a negative 3, real number. I get a positive 3, real number. 3i imaginary and negative 3i imaginary. Okay? How's that? And I'm going to stop recording. Where's my little record? Where's my little button? Stop recording if I can find my little thing. Oh, here it is. It's hiding under my calculator. Okay?